Legend has it that Glastonbury was the seat of King Arthur, and even the resting place of the Holy Grail. What's less well known is that until recently, it was also the centre of a healthy printing industry. Local authoress Frances Howard Gordon has just published a guide to local myths and legends and wants a properly printed press release. Normally, getting a manuscript set into type by a printer is expensive and time-consuming. But a new cottage industry based on the microcomputer has just sprung up in the area.
The copy you've got here is clean enough for us to read on the reader. So, hang on a minute. OK, go. Watch.
An optical character reader does away with the need for retyping. The typewritten page is scanned line by line, and the words are read directly into the microcomputer's memory. Once it's in the machine, errors can be corrected and the text manipulated in a variety of ways.
That's got it all in anyway, but since it's you, we're supposed to be able to run the spelling checker.
Don't be rude.
Gog, well, that's the name of that tree, isn't it? We'd better tell it to accept that.
Oh, it doesn't know that, no.
Faces. Oh, you've got another spelling error there. Actors.
Oh.
When the text is correct, the next thing is to choose how it's going to appear when it's printed.
12 point will probably do for main text. And if we go for, say, about maybe 16 or 18 for your heads, what about emphasis, bold or italic?
Bold in the heading, yeah.
So we need this in a larger size, so we'll just call it head.
Once Frances has chosen the sizes and styles of the final print, commands are put into the text to define how each section is to be printed.
We wanted to put all these Glastonbury Maker of Myths into italics. And we do that with an instruction in which
the machine searches through its memory, and everywhere the word Glastonbury appears in the text, the cursor stops and gives the operator the chance to decide whether he wants to set it in italics or not.
And let's just go and find it in each case. Well, that's one we don't want, so we'll give that one a miss. That's the one we do, so let's go back.
When they're happy with the text, it's sent directly to a photo typesetting machine. Each letter is drawn individually by a flying spot of light onto special photographic paper, ready for printing. So here's Frances's finished document. As you can see, Glastonbury, Maker of Myths, is put into italics. Well, it was only a short document, but a whole book could have been set in type in only a short time using the same system. To carry things one stage further, of course, she could have put her manuscript straight into a word processor and sent it to the printers by post on a floppy disk, or even electronically down the telephone line. But how does a computer handle words? Well, it's important to make a distinction between numbers, on which we can do arithmetic, like the number 12, 2 12s, 24, etc., and strings of characters, by which we mean a collection of letters, symbols, spaces, and so on, such as the word 12, T-W-E-L-V-E. Well, I can best explain this difference by looking at a short program I've got here. We define a variable first equals 12, the number 12. We're going to print it, and then we're going to do a little bit of arithmetic on it, print first plus 1. Let's run it. Well, as you'd expect, it prints out 12, which was the variable first, and then it adds 1 to it and prints out 13. But if we wanted to handle strings of characters using the basic language, there are two things we have to do. First of all, we have to put a $sign after the variable name, and we have to enclose whatever we're going to put into that variable in quotation marks. And we'll write a little program, a new program. And that's a very simple program. We'll do it the same sort of way. First, and we put in the $sign equals, in quotation marks, 12. And we'll print it. Print first, with a $sign again. And if we run that, we get 12 printed out. Now, of course, you can't do arithmetic on variables that are string variables, and it's quite interesting to see what happens if we try. And we'll copy that line, print first, and then we'll add 1 to it, plus 1. And we'll run it. And immediately the computer analyzes that we've made a mistake. Type mismatch at line 20. And what this means is that we're trying to mix up a string variable, first with a $sign, with a number 1, which you can't do. But of course you can do certain things with variables, and you can actually use the plus sign. And we'll just copy that command again. Print first plus, and in inverted commas, which means it's a string variable, 1, and we'll run that. and it prints out 12 with 1 added on to the end of it. So what can we do with string variables once they're in the computer? Well, in any decent version of BASIC, you'll remember there are almost as many dialects as there are different kinds of machines. There are a series of commands which are concerned with the handling of strings. Now, we can't go into a great deal of detail, but you can get an idea of how these commands are used if we take an example. Just have a look at these. What have they all got in common? Well, you've guessed it. They all read the same backwards as forwards. In other words, they're palindromes. So how could we instruct the computer to decide whether a word is a palindrome or not? What kind of things would we have to do? Well, let's create a couple of variables, string variables in this case. We'll call one word string, which is the word we're going to put in the computer to test whether it's a palindrome or not. And the next one we'll create is called backward string, which is the word we put in backwards. Now, to get it backwards, all we have to do is to transfer characters one at a time from word string, and starting at the end character into backward string, and add it on to the end of whatever is in backward string until we've completed all 4 transfers. And then we've created the word backwards in backward string. Then we test whether this word is the same as that word. If it is a palindrome. If they're not the same, then it's not a palindrome. Well, we've written a fairly simple little computer program. It's only got 5 instructions, and we can see how that's done on the machine itself. And here it is. Well, you can see the first instruction, input word string, is asking us to input the word we're going to test whether it's a palindrome or not. This is the basics of the program, the loop, which is going to move character by character the characters from word string into backward string. And what it takes is, for place equals len word string, that's the length of word string. In our case, it's 4 characters long. We're going to start at the 4th character, that's the end of the word, and we're going to go backwards, so we go in steps of -1, and each time we get to next place, it will subtract 1 from the 4 we had and loop around this loop 4 times. This instruction 30 is an intriguing instruction, and what this is going to do is actually carry out that move, and it knows what to move by this function here, mid-string, and all this says is take the character which is at 1 character at a time from the position place. In the first case, it's 4. So take the 4th character, one of them, from the word